All right, section 13.1. And we are doing the Algebra 2 book. So we're doing some Algebra 2. But this lesson right here is exactly the stuff that we did in geometry. All right, so this is kind of just review. They might throw a couple little things in there that's a little bit different. But for the most part, it's exactly the same stuff that we have done in the past. All right, so we are going to talk about trig functions and right triangles. So I'm just going to write trig functions. You should be taking notes on this, even though we have done it. Did it in chapter 8 in the geometry book. So we're only going to deal with right triangles in this section. Not this chapter, but just this first section. We're going to deal with right triangles. So let's just review briefly here about our trig functions. And let's say we use this angle right here. We'll call it theta. And I believe they will start calling things theta in this book. They do. I remember we talked about that in the Algebra 2 or geometry book. In the geometry, they don't use theta. I said eventually you will, and they sure do on this chapter. It's just an unknown angle. Just means you could use any letter that you want. It's a Greek letter of the alphabet that just represents an unknown angle. Okay. So if we're talking about this angle right here, and we have a right triangle, because this whole section is about right triangles, we have some sides. Let's name our sides. So let's talk about this side right here, this slanty side right here. What would we call that? Here's our right angle. What would we call this slanted side? Right, that would be the hypotenuse. Okay, this is all review. What about this side over here, this little tiny side going up and down compared to this theta? What would this be? Which leg, though? It's opposite. It's opposite. Okay? Remember, this is trig functions. It's opposite the angle that I'm talking about. What about this side right here? What is that to this angle? It's adjacent. All right? So we remember that. And we had, well, we had 3 different trig functions. We're actually going to learn 3 more. But the 3 main trig functions that we learned, do you remember this? The sine of the angle, the cosine of the angle, and the what? The tangent of the angle. So let's put that stuff in there. We had a little memory device, didn't we, to remember this? SOHCAHTOA, good. So SOHCAHTOA. My writing is a little messed up today. So let's do this. Let's do the so part. So sine of theta. So the sine, if you look up here, this is our little memory device, mnemonic device they call it. So it's OH. What does the OH mean? Opposite over hypotenuse. All right. So it's the opposite. Let's just put some numbers in here. Nah, we'll just put the letters. We'll just put the letters. We'll go opposite over hypotenuse. All right. What about the cosine? What's that? It's adjacent over hypotenuse. And this is how you remember it, but this is what it actually is. Then the tangent is OA, so it's what? Opposite over adjacent. All right, no big deal. And we actually had inverses of these. I think I might have mentioned it in passing when we did this. I didn't make you remember it or anything, but there is an inverse of the sine, which means if I flip the opposite and hypotenuse, they have another trig function that represents the inverse of the sine, and that would be the cosecant. Cosecant. I'll write the word out, and then I'll show you how to shorthand it. Okay, so it's cosecant, and it's CSC. That's how we shorthand it. Now, it's the inverse of the sine. So when I take the inverse of this fraction, what am I doing? I'm just doing what to it? Just flipping it, right? So what would the cosecant be? Yeah, I'll just flip it, right? It's the hypotenuse over the opposite. Now, do we have a fancy mnemonic device like we did here to remember all these inverse functions? Nah. I just remember that the cosecant is the inverse of the sine. And then if I know the sine is opposite over hypotenuse, all I do is just flip it, and I go hypotenuse over opposite. All right? This is the only thing that's really new to what we did in Chapter 8 in geometry. Go ahead.
That's only for sine? Is that for every trig function?
That's the inverse of, that's just the inverse of the sine function. We're going to do 2 more inverses.
So there's a different one?
Yeah, there's a different one for cosine, there's a different one for tangent. Okay, this is just the inverse for the sine. Now, the inverse of the cosine is called the secant. And we just shorthand it SEC of theta. Now, the secant is the inverse of the cosine. So you look over there at the cosine is adjacent over hypotenuse. So what would the inverse of adjacent over hypotenuse be? Yep, it'd be hypotenuse over adjacent. All right, all I do is just flip it. It's the inverse. You just flip the fraction. So instead of adjacent over hypotenuse, it's hypotenuse over adjacent. Then we have another one. It's called the cotangent. Cotangent. All right, and we just put COT for cotangent. Now the cotangent is the inverse of the tangent. So if the tangent is the opposite divided by the adjacent, then the cotangent is adjacent over opposite. Now, do I have these memorized? I don't really have these memorized like I do these, but I do have this memorized. I do memorize that the cosecant is the inverse of the sine. Okay? So I know what the sine is, opposite over hypotenuse, so the cosecant's the inverse, so I just flip it. It's the hypotenuse over the opposite. Same with the secant and the cotangent. The big problem is people getting mixed up between which one's the inverse of what. This is how I remember it. Remember, they're inverses of each other. They're different, right? They're flipped. So if you look at this, a lot of people that think that the sine and the secant are inverses of each other. But they're not, because they both start with S, but that they're not inverses. So inverse means they'd have to start with something else, right? So the sine is the inverse of the what? Cosecant. So the sine and the cosecant are inverses of each other. Does that make sense? So if you think sine secant, no, that can't be right because they both start with S. They got something in common. Nope, I want to flip it. They're inverses. So I think, oh, S and C. If one is S, the other is C. You get it? Same thing with this one. What's the inverse of the cosine? It's the secant. All right, C and S again, right? They're inverses of each other. That's how I remember it. It's not like any, cool fancy way like this SOHCAHTOA, but that's just how I remember it. I just remember they're inverses of each other, so the sine has to be the opposite letter as its inverse, so it's the cosecant and the sine, and the cosine and the secant. Now, with the tangent, that's kind of easy to remember which one goes with what, doesn't it? Because tangent, cotangent, they're opposites of each other, so that's pretty easy to remember. That's usually not a problem. It's the sine and the cosecant and the cosecant and or the cosine and the secant are the ones that people get confused about. Does that make any sense at all? All right. So let's set up a little example with this.
Is there a button on calculator for it?
There's not.
Or do you just plug it in for
Let's see what we're going to do here and see what they ask. They're not really going to get into the secant, all the inverse functions very much on this at all. In pre-calc, they'll start dealing a lot more with secant and cosecant and cotangent. They're just kind of touching on it in Algebra 2. Maybe in the next chapter. We won't get to the next chapter, but 14 is, it's a little more heavy-duty trig. This is real basic introductory trig. It still is, okay? It was in geometry. It still is in chapter 13. Chapter 14, I think it's 14, let me see. Yep. Chapter 14 in the Algebra 2 book is definitely a little more heavy-duty stuff. We won't get to that this year. I'll let you do that next year, okay? But this will be good practice for you. At least it gets it in your head one more time so that when you eventually do get it, and you won't get it to the end of the year next year, unfortunately. It'd be nice if they would teach it kind of earlier on. But they're doing this chapter actually right now. So you won't see this until the end of the year next year. But who knows? Some of it may stick. We'll see. Let's do an example here. I'll just do the one right from the book. I know you don't have a book, but this is right from the book.
Why are we doing that now?
Because I want you to be ready for it. I don't know, after this. So let's do this. Let's put a 17. I'll have to see how it. I'll have to see how it pans out. It might just be on the final. I don't know if we'll have a full test on this just because of our time restraints. Okay. So I would say it's probably going to be a handful of problems on the final. That would be my guess. All right. So what if you wanted to do this? Let's just do this really quick. It will be, yes, just like the midterm, 40 questions. And it just covers whatever we did in the second semester. I forget exactly what chapter that. We'll look back on it at some other point. But we still got a little time here. So let's do the sine, cosine, and tangent of this triangle. And we're also going to do the inverse functions, okay? So we'll do the cosecant, we'll do the secant, and then we'll do the cotangent. of that same angle. All right? It's really not that hard. Look, they give you all three sides. You don't have to find the angle. They're not even asking to find the angle. They just want you to find what is the sine of the angle. They will eventually. Yeah, we'll do that in the next example. Okay, we'll actually find the angle. And we could do it in this example, I guess. But let's just do it what they want you to do. They just want you to find the sine of the angle. That's it. So what's the sine? It's opposite over hypotenuse. So what's the opposite? And what's the hypotenuse? 17. That's it. That's all they want. That's the sine of the angle. What's the cosine of the angle? It's adjacent over hypotenuse. So what's the adjacent? 15 over 17. Good. What's the tangent? Well, they don't reduce. You should if they can, but these don't. These don't reduce. What about the tangent of the angle? It's opposite over adjacent. So it's 8 over 15. All right? Now watch this. This is kind of easy. The cosecant, it looks weird, looks crazy, but the cosecant, don't memorize it's this over this. Just memorize it's the inverse of the sine. Yeah, that's it. So it's just 17 over 8. So once you find the sine, the cosecant, you just flip the fraction. It's pretty easy, isn't it? Yeah, when you write it next to each other, exactly. And that's why I did it, because it's the first time you've seen it. So that's why I put it right next to each other. What if it was just sitting there by itself and you had nothing around it? Well, what I would do is this. I would say, oh, the cosecant is the inverse of the sine. The sine is opposite over hypotenuse. So what's the inverse? Hypotenuse over opposite, so it's 17 over 8. Okay? So the secant. The secant is, again, let's cover this up. Let's cover this. Oops, that didn't work too great. Let's do this. Boom. There we go. So let's cover that up and let's look at the secant. Well, what's the secant the inverse of? The cosine. So the cosine would be what? Adjacent over hypotenuse, 15 over 17. So what would the secant be? 17 over 15. So that's pretty easy, isn't it? What about the cotangent? The cotangent is the inverse of the tangent. The tangent is opposite over adjacent. It's 8 over 15. So we got to do the inverse of it, so it's going to be 15 over 8. See how easy that is? Yeah. And if you look, get rid of this again. Look, they're just inverses of each other, aren't they? All right? Pretty easy, right? What if you wanted to find this angle right here? You really wouldn't use cosecant, secant, and cotangent to find this angle. You'd use your basic trig functions, okay, to find what this angle was. Like, because you don't really have buttons on your calculator that say cosecant, secant, cotangent. So what if, let's just say they told you the cosecant was 17 over 8. Well, what would that tell you? That would tell you that the sine, right, of the angle is 8 over 17. You see that? So you wouldn't really put this directly into a calculator. What you would do is you change it into one that's a button on your calculator, which is the sine. And now, how would I solve for theta? You remember doing this? How do you get rid of that sine? You don't divide by sine. Do the inverse sine. What does that look like when we write it down? Right. Good. Sine to the negative first. So you remember something, right? From back then. It doesn't? Are you in degrees? Make sure it's in degrees, because sometimes the calculators default to radians. Go to mode. Go to mode. And then, here, I'll show you. Watch. If you go to mode, well, I got to turn it on first. If you go to mode, it's the third one down. So you see radians and degrees? It should be on degrees. If it's not, you need to do it that way. We'll talk about, I think this chapter talks about radians a little bit later.
So to find theta, you don't have to use sine, you can use...
Oh, you can use anything. If you know all three sides, yeah, you can use any of them. Right, it doesn't matter. In fact, let's just do that just for fun. Let's just see how it works out. Okay? Watch. So I'm going to take the inverse sine of 8 over 17. So I hit 8. Oops, let's do it like this. Let's hit second function sine of 8 over 17. 8 divided by 17. Okay, let's see what we get. We get 28.07. So 28.1 degrees. Let's just say 28 degrees. Let's go 0.1. So 28, actually let's do this. So theta is 28.1 degrees. Now watch, this, it should still work with cosine and tangent. So let's see if it does. So I'm going to go second function cosine, but this time what am I going to put in? 15 divided by 17. Okay? Same exact number. Exactly, isn't it? All the way to the very last decimal.
Do you get a different number if you try to find theta with cosecant or secant?
No, because if you try to find it, you're going to turn it into sine anyway. Remember that? You're going to take the cosecant, turn it into sine anyway, and then it's going to be exactly the same as this. So you'll still get the same exact answer. What about the, let's go inverse tangent of 8 divided by 15. Same exact number, all the way to the very last decimal. So it doesn't matter which one you use, does it? But yeah, if they give you the cosecant of an angle is this, and they ask you to solve for the angle, let's say the only thing they gave you was this thing in the box. They didn't give you a picture, they didn't give you anything. They just said the cosecant of an angle is 17 over 8, find the angle, find theta. And I don't think they're going to, but they could, all right? So what would you do? Yeah, I would go 8 over 17, then take the inverse sine of it, and then you can find it. And that's, you just have to recognize that the cosecant is the inverse of the sine. So don't just take second function. There is no cosecant button on your calculator. All right, so you change it to sine, and then you take the inverse function, and then you're good to go. Make sense? All right, let's move on. Do you remember your special right triangles?
Yeah.
Your 45. Not the. Yeah, the special angles as far as the special triangles as far as the angles are concerned. Excuse me. So we have this. If these two sides are equal to each other, it's an isosceles right triangle. What do these angles have to be? They have to be 45, correct? Because these two angles add up to 90. They both have to be the same because remember, angles opposite equal sides are equal to each other, right? It's all coming back to you. Yeah. See how it all comes together, doesn't it? And then I'm not going to go through the y's on this. We did it in geometry, but we had a little thing here. We said the hypotenuse is equal to the square root of 2 times one of the legs. Remember that?
So if you go over it in algebra, why do you do it in geometry? Like,
because people forget. And people forget, and also it goes a little bit more, right? The stuff that you learn in Algebra 1 in geometry, you probably took it just a little bit further. Well, we learned this in geometry. Why would you do it in Algebra 2? Because they're going to take it a step further. Okay, remember, high school is just a foundation. It's just foundational stuff. It's not like it's the end-all and be-all of all math, right? It's just giving you a place to stand on so that you can actually do some real math later on. This is just basic. I know, thinking, oh my goodness, what's real math look like then? Yeah, it's complicated. That's why not everybody does math, to that level. But there are a few, that can do it. But this is foundational stuff. Let's do this triangle right here. It's a right triangle. And if I said this was 30 degrees, what does this have to be right here? It's got to be 60. Now we have two things. Excuse me. Remember we had a short leg. We had let's scooch this down a little bit. We had a long leg. And we have the hypotenuse. Remember that? So we had, I always said it was the most important side on a 30, 60, 90. What is it? It's the short side because they both relate to the short. The hypotenuse has a relationship with the short angle, and the long side has a relationship with, the short side of it. The long has a relationship with the short, and the hypotenuse has a relationship with the short. Hypotenuse is the easiest one. The hypotenuse is how much of the short one? It's always twice as much, so it's 2 times the short leg. Okay? Just double it. That's all it is. Hypotenuse is always double the short leg. The long leg, it's equal to what times the short leg? Remember the number?
3.
Square root of 3. How do I remember that? Because 2 is the square root of 4, isn't it? Would you agree? Yeah. 2 is the same thing as the square root of 4. Well, the long leg is just a little bit shorter, a little bit smaller than the hypotenuse. So what's just a little bit smaller than the square root of 4? Square root of 3 is. And then it's both times the short leg. So this is what you need to memorize for 30, 60, 90. Okay, let's do an example. Oh, actually, you know what I'm going to do? With that in mind, let's do this. I kind of skipped an example, but we kind of did it up here. When we found that angle 28.1 degrees. That was kind of part of the example that they gave you. Let's continue with this though. Yeah, let's just go right here. I think we might have talked about this. There was one problem that I'm like, wow, I'm surprised they gave that to you. But what we're going to do is this. There's some special angles. So let's go back to the 45, 45. What we're going to do is we're going to find the sine of 45 degrees. We're going to find the cosine of 45 degrees. And we're going to find the tangent of 45 degrees. Without just putting it into our calculator. I mean, you're like, well, I can just take it out my calculator and get a number. Okay, but what I want to do is I want to find exact values, which means if you put it into a calculator and it comes out to a decimal, is that exact? So if I put sine of 45, watch, the sine of 45 into a calculator, you get this number. That's not an exact number. It doesn't stop at 2, does it? Keeps on going. It's just my calculator's not big enough to hold all the numbers. In fact, no calculator would be big enough to hold all the numbers. Why not? Because it goes on what? Infinitely, forever and ever, okay? So that would not be an exact value. We just barely have enough time to get this. So we may be behind a day. Actually, maybe not, because I kind of split this into 2 days. So we'll be fine. This is 45. And this is 45. Now, we'll probably talk about this later on this chapter, but this is what I'm going to do right here. They do it a little different in the book. But you don't have the book anyway, so it won't make any difference, will it? What I'm going to do is this. I kind of like this way better. I like to take this hypotenuse, just make the value of it 1. You're thinking, well, how can I just make it a 1? Well, just trust me on this, okay? Just make this a 1. All right? Now, what I want to do is I want to figure out what this side's going to be and what this side's going to be. Now, they're both exactly the same, aren't they? Remember that? So, what is the hypotenuse? The hypotenuse is equal to what? The square root of 2 times one of the legs. Well, what do I know here?
1.
I know the hypotenuse. So 1 equals the square root of 2 times what? Call it x. That's one of our legs, right? How do I get x by itself? Divide by the square root of 2. Let's simplify it. Do you remember how to simplify this? Yeah. Multiply the top and bottom by the square root of 2. All right. So that's the square root of 2. What's square root of 2 times square root of 2? 2. So let's write it real nice and pretty. This is the best way to write it. Square root of 2 over 2. And what's this x right there? It's the square root of 2 over 2. You're like, why did I go through all that? How's that going to help me find the sine, cosine, and tangent? Well, I'm glad you asked, because watch. This is 45 right here. What is the sine of 45? The sine is the opposite over the hypotenuse, isn't it? Well, what is the opposite? Square root of 2 over 2 over the hypotenuse, and it's a 1. So what's the sine of 45? Just the square root of 2 over 2. What about the cosine? Because it's over 1. It's over 1. Do we really need to divide by 1? No, because you divide anything by 1, it still stays the same, doesn't it? Right, so I didn't even have to worry about that. Isn't that nice that my hypotenuse was 1? Because when I divide by 1, I didn't have to really mess with it.
So
that was cool.
Find the exact value, you just want to use 1 as the hypotenuse?
You could use any. Now, if I had more, yeah, see, there goes our time. But watch, you could have made this a 5 if you wanted to, and gone through all this stuff, and it would reduce down to the square root of 2 over 2. All right?
So it was 45, 45, 45.
Yeah. So what's the cosine? Watch this. The cosine is adjacent over hypotenuse, which is the same exact thing, isn't it? Let's do the tangent. The tangent is opposite over adjacent. Look at this. What's the opposite? Square root of 2 over 2 over the adjacent, which is square root of 2 over 2. What's anything divided by itself? It's 1. So watch. Check those on your calculator and see if it comes out that way. All right? I was going to give you a worksheet. I think I'll wait till tomorrow to do that. We'll finish this up. This is a little bit lengthy, a little more lengthy than I had anticipated. So we'll finish this up tomorrow.